In complex numbers 1, we're going to look at complex roots, and we're going to introduce I squared for the first time and the letter I for the first time. You can see here straight away, if I squared is equal to minus 1, which is what we're always told in these complex numbers questions, then I, if I get the square root of both sides, is equal to the square root of minus 1. So that's what we're going to introduce in this video. Now, normally they use the letter Z in complex numbers, but I'm just going to start with x. So let's look at the equation x squared minus 2x plus 5 is equal to 0. You can see here we wouldn't be able to factorize this because 5 is prime and we can't make 2 out of 5 and 1. So let's use the minus b formula, or the quadratic formula. Minus b, you all know this off by heart now, so this will be the only time I write it out. Minus b plus or minus the square root of b squared minus 4ac all over 2a. A is equal to 1, coefficient of x squared. B is equal to minus 2. And c is equal to 5. So plus 2 minus minus 2 plus or minus the square root of b squared, so minus 2 squared minus 4 times a, which is 1, times c, which is 5, all divided by 2 times 1, 2a. So we're going to get 2 plus or minus the square root of, now this is what happens in complex numbers, we get a minus number inside the square root sign. We're going to have 4 minus 20, which is minus 16, which up until now we have not been able to get the square root of, but in complex numbers we can. And it's based on this third rule here. So the square root of minus 16 is equal to the square root of 16 by the square root of minus 1, based on our rules of thirds, which is equal to 4 times the square root of minus 1, which based on our rules from complex numbers is equal to I. So the square root of 16 is 4, the square root of minus 16 is 4i. So we end up with 2 plus or minus 4i over 2, which is equal to 2 plus 4i if we want to separate it over 2, and 2 minus 4i over 2. So this gives me 1 plus 2i and 1 minus 2i as my two roots. What's going to introduce here the sum and product of roots, sum and product. So what happens if we add these two together? This 1 plus 2i, add 1 minus 2i, we're just going to get the number 2. And if we multiply them, 1 plus 2i multiplied by 1 minus 2i, we're going to get 1 minus 2i plus 2i. So it's like the difference of two squares from junior cert. They cancel and we're going to get minus 4i squared. But what are we told I squared is equal to? I squared is equal to minus 1. So minus 4 by minus 1 becomes 1 plus 4, which is 5. So let's just look at our equation. We have a 2 and a 5 for the sum and the product, and we have a minus 2 and a 5 up here. So this is going to introduce all these complex equations, and quadratic equations can be written as z squared or x squared minus z or minus x times the sum of the roots. So our sum was plus 2, we have a minus 2, we change the sign, and then we add the product of the roots at the end. And this is just another version of factorization from junior cert, plus the product of the roots, and that will be equal to 0. So you can see here, if we're given these, we can create our equation by just adding them, changing the sign to our answer, and multiplying them and keeping the sign with our answer. So let's have a look at another one. Let's have a look at x squared minus 4x plus 20. X squared minus 4x plus 20. Minus b is 4, plus or minus the square root of b squared, which you can put in 16 straight away, minus 4 squared, minus 4 by a, which is 1, by c, which is 20, all divided by 2, or 2 times 1 if you want. So we have 4 plus or minus the square root of 16 minus 80, which is minus 64, and you'll see these work out to be these square numbers quite a lot, sometimes thirds, divided by 2. So we have 4 plus or minus 8i over 2. So you're going to get 2 plus 4i and 2 minus 4i as your roots. These are your roots. Add them together, we're going to get 4. Change the sign, we get our minus 4 multiply them. 2 plus 4i by 2 minus 4i. 4, and then you can see the middle two terms are going to cancel, so it's just 4 minus 16i squared, which is 4 plus 16, which is 20, which is this number here. So just introducing complex roots, and what complex roots are where it doesn't cross the x-axis, this quadratic. So it could be like this, could be over here. If it touches off at once, it's a double root, and b squared minus 4ac is equal to 0. If it touches off it twice, b squared minus 4ac is greater than 0, and if it doesn't touch off it at all, b squared minus 4ac is less than 0. So just write them out. B squared minus 4ac equals 0 for this one root. For two roots, and these are two real roots, b squared minus 4ac is greater than 0. And then for no real roots, b squared minus 4ac is less than 0. And b squared minus 4ac, you've seen this in another video, is known as the discriminant. So just a little introductory into complex numbers.